What's up guys, Bacon here from Eternode. So with us releasing enAPI and making a little write-up about it, I kind of figured maybe I make a short little video what enAPI really does, what it could do for you, what it could help you with maybe, and what you can build on it. And then I'll also go into a little bit what we're also planning on building on it and have built already. But basically enAPI is a json-rpc 2.0 API built with etc labs Open-RPC spec. It's based on nodeJS, TypeScript, and Pristine. Basically, this is just a little framework or API, I should say, that you bundle it together with MongoDB and multi-graph based, but we provide the multi-graph containers, Docker containers. I'll go into that in a little bit. And it lets you manage your nodes, right? Lets you host your nodes, manage your nodes. This is just the back end, doesn't come with a UI, but here's the documentation actually. So basically I'll go along with this and in this video, as I also have some examples in Postman that I'll be kind of going. So as I'm kind of going through these examples over here, I'll be showing both the documentation, and this documentation was created with the Open-RPC spec using the Open-RPC playground. You kind of can see split window over here. And yeah, and basically they build a whole playground, they spits out the doc. Pretty beautiful thing, bundled with Pristine, then TypeScript. They have a whole set of tools. It's really interesting. I recommend checking it out, open-rpc.org. But getting back on topic, basically, like I said, helps you manage, basically even on a whole level of creating users that get to log into your interface that you create, to create nodes, spin up nodes, and then you can administer them for them or whatnot as well. So let's kind of start off with here. I'll put a Postman, and we'll go by each method. We got create account, login, check for users, get user, delete user, and then add node, get node container info, and then a couple of little custom additions that we have for an IPC client that we've created, that you can make Web3 calls directly through your node through our IPC client without needing to open up your WebSocket or HTTP JSON-RPC ports, which are supported as well too, and we'll show in this video as well. So when you first start off, make sure that on your Linux distro you have MongoDB and Docker CE at least pre-installed. Those are the two major components, and obviously this is a Node.js application, so you're required to have Node.js and npm, and our GitHub page has a little bit step-by-step more information on how to get enAPI installed onto your Linux distribution. And we also provide script files for Ubuntu and Debian-based devices, either for x86 or ARM. But once you get enAPI running, it's recommended you create an admin account. So we'll create one, Bacon, password, pass an admin. Once you create an admin account, you get account created and log in. You will need to log in to receive your token, and you will need to pass this token in every first parameter for every call pretty much afterwards. We'll go over this as well. But kind of going back to quickly the documentation, right? Create user right here. It tells you, it takes these three parameters, username, tells you it's a type string, and that's all created by you and defined by you. And it's got examples, errors you could receive. So really neat stuff to help you along with your development as you're coding, to learn how the API works exactly inside and outside, right? Login tells you username, password. And there is actually a description. So yeah, going back to Postman, these parameters are all aligned out in the playground. Now, after you get your token, logging in and needing it, let's do get user. So you can log in, you know your username already, and we'll do the method called get user. You put our token in, send, and we get information back about the user. He's an admin, ID, and no nodes. So this main reason for this whole thing is nodes. Nodes are easy. Same thing. Put your token in. What user is the node being created for? Usually yours. That's all supported. You just have to pass it, because I will explain a little bit in a second how node creation works. Node name, basically the flag that you pass with multi-gap for what network you need, and whatever network multi-gap supports, and you pass in here, this will spin up that type of node for you. Node name, your custom name that you want. I'm calling this Scotty. Sync type, fast. We support both fast and full at this point. Archiving is coming up, and just got to make sure that you have enough hard drive space for an archive node. And these last two parameters are if you want to open up your HTTP, json-rpc, or WebSockets. HTTPS and secure sockets will be implemented next as well, so you'll be able to do that as well without any issues. But what happens when you create a node? So press send, created a node. We can verify that node's been created. Another verification is you can take the node ID and use the method get node container information, and I'll explain in a second why container. And we might get an error. Oh yeah, I already used this token. So you can see the containers running, the RPC ports, and the WebSocket ports that are assigned to it. And what happens basically is we've created multi-gef Docker containers, and what happens is the minute the container spins up, it also creates persistent storage for that container on the device that enAPI is running on. And a little bit when you're following the instructions how to install enAPI, and touches on creating the directory for that actually. Why do we do this? Because obviously, even great example, the upcoming Atlantis fork, upgrading your node software, right? It's easy. With containers that have persistent storage, all you're really doing is re-downloading your Docker image that's got the newer multi-gef or whatever your favorite client is in, and then restart it, reattaching it to the same persistent storage spot as previous, and you can continue on from your chain data, retaining pretty much all data as nothing pretty much happened, unless it's some type of a big update to your client that changes database types or whatnot, and then we're hoping that you have some type of a converter too as well. So, but that's a whole nother story. So here you are. That's literally it. If you want to see that the container is running, this brings us to the other options over here where we have FRPC. We've created our own client. Basically, with this client, you call the method FRPC call. You provide the username, which is you making the call, the node name, the node network name, the node name, and obviously the Web3 call, Web Client 3 version, the parameters for the call, and json-rpc. This is the json-rpc 2.0 standard over here, and you make a send. Why would you do it this way? This just gives you an extra security layer to make calls to your node without exposing any ports or anything at all, and returning them to your front end. If you remember earlier in this video when I did get node container info, we got the RPC port. So let's use this now. And here is just a normal Web3 call. We're going to change this RPC port to what we had over there. And obviously, if this is exposed on your network, you have to make a direct call to your node without having to use our client, IPC client. And yeah, pretty much with this, you can generate as many nodes you want for whatever networks you want. So obviously, Kari over here, let's do a classic container quickly. And once again, because I feel like maybe I haven't really talked about it enough in this video, but all of these properties for these methods, json-rpc methods, you can view them in our playground. And one quick thing is, forgot to kind of show, you can view the playground in dark mode and light mode, whatever you prefer. But yeah, so like right over here, let's look at the add node property, right, and add method, I should say, and it'll give you an explanation, spin up a Docker container with node settings, pass fnet if you're spinning up Ethereum mainnet. And that's only like that for right now, because especially with multi-gef, since it doesn't really take a flag for Ethereum. If you want to spin up an Ethereum container, just press fnet. But you can see that the parameters it's waiting is it wants the JW token, username, node network, sync type. So you light, fast, full archive sync. Obviously, we're still working, as I said. Fast and full are fully supported right now. Then fast RPC API and WebSocket API, and you can see examples over here. Going back quickly just so we can finish this off. So you can add multiple nodes. So let's spin up a classic node, and here it is. And then we can check the nodes and node, and it pops up over here, classic. Now we have 2 nodes. Here's our node ID. So let's just double check that this node is running properly. Let's get the RPC for this node, and it's running. Here's the RPC port. So again, you have our method. I don't have a method for the net version. So like over here, you got version, body, the call is net version. So let's do localhost, and I'll show you a cool trick actually really quickly. Localhost 32783, and here we go, result 1. And what else? So one cool thing about what we do with our RPC client is, even though this one is set up for Web3 client version, like I said, you just replace what Web3 call you want to make with ours with method, and you get pretty much the same answer back, except with, well, maybe you don't. So the error I got actually is not that it works. Let me fix this up really quickly. Is what happens right now, the system where my enAPI is running right now, when it creates the persistent folders that I told you about, I have my my settings for my user permissions set up a little bit goofy at this second. So let me just challenge this really quickly over here. And because what happens when the persistent folder gets set up, it gets set up as a root user, and when I try to connect to the IPC socket through the IPC file, it throws an error, an access error. So let me just finish this really quickly. Just doing this off screen, give me 1 second. And here we go, npm start, let's start the API. Okay, just starting up the API, it's compiling, well, nodeJS, so, here we go, and there we go. And here's the result. So since we're calling the Kadi, result 6. So here it is in a nutshell, an API, really powerful, let you spin up nodes with few and simple API call. Once you set up an account, literally just one call, add node with a couple parameters. Once again, you can view all of this in the links in the video over here to get to our GitHub page, get guidelines how to set it up quickly. And yeah, we're working on one-click setups, and right now currently I've run this very successfully on ARM64, like Rock Pro 64, and Ubuntu setup on almost any AWS, anything, and CentOS setups, no problem. As long as you can get Node.js, MongoDB running, and Docker on your system, then this should run without a problem. Thanks for watching, and stay tuned for future videos. Thank you. Bye.